Alright, for this example, we have here a problem that deals with the ball leaving the edge of a table that contains initial horizontal velocity. So this one would still fall under projectile motion, but with an initial horizontal motion. Okay. Given that uh, idea, we can still be able to identify this under uniform accelerated motion because the moment it leaves the edge of the table, it would only experience an acceleration due to gravity, which is, as you all know, constant. Okay, so with that being said, we can now apply our equations of motion, given that this is still under uniform accelerated motion. So the first thing that you need to look at here is that since we're looking for v, okay, v is actually velocity along the horizontal axis. Okay, now the simplest way to solve this is actually just using a simple equation, which is speed equals to distance over time, right? Given that if we know already the speed or the velocity in this case, this one, and the distance is already given 1.5, we can just simply solve for the speed. The problem is we don't have the time. So we need to solve for the time first, then we can solve for our velocity. So let's proceed on solving time. What are the equations that we could use, or what is the equation that we could use in order for us to solve the time of the ball as it reaches the maximum range? So most likely, given that it starts off with um, zero zero velocity along the y-axis, we can actually use that value. Okay, so what do I mean by that? So s is equals to ut plus 1 half at squared. Given that there's no initial velocity along the y-axis, this will become 0, right? Then we can actually find out this value, but we need to at least make time as a subject of our equation. So we're going to do some a little bit of um, algebra. So t here would be placed here. Then that will be s multiplied by 2 over a then square root. Okay? Then from here, solve for the value. That's 2 times 1.25 all over 9.8. Okay? 9.8 is the value of our acceleration due to gravity. The acceleration here is acceleration due to gravity. All right, so let's solve for that. 2 times 1.25 divided by 9.8, and you will get 0.51. Okay, 0.51 seconds is the time that we need to reach 1.5. Now you might ask, sir, why are you not using 1.5? Um, when I use this equation, I'm only focusing on the vertical components because at that point my initial velocity along the vertical axis is actually 0. So I can eliminate this part, okay, and I will be left with this one. Then from there I can already solve for my time. Now, since I'm dealing with the vertical components, I'm also using the vertical distance, which is 1.25. Take note that the time that you need to reach 1.5 is the same as, traveling from that 1.25 distance vertically. All right, given that time, we can now solve for the distance. S is equals to 1.5 all over 0.51. Okay, 1.5 divided by 0.51, and you will get 2.94 meters per second as your velocity. And this is how you solve for your horizontal velocity.